All right, percent test review, SAT style. Let's get after this. Go all the way down. Number one, according to nerdwallet.com, the average new car depreciates 25% during the first year. So remember, depreciate is a decrease. Price is going down. New cars always lose the most value the first year. The car then depreciated about 15% during years 2 through 6. So that's our next clue. Depreciated 15% years 2 through 6. If you bought a new car for $30,000, how much will it be worth after 3 years? All right. Well, here we go. It's kind of the same setup we've been running. You know, you have your original. And then very similar to a discount is we're going to depreciate. This is year number 1. This is going to be year number 2. And this is going to be year number 3. And that should give us the value after 3 years, you know, or the end or the final price. Now, depreciate 25%. That's a 1 minus 0.25. The second and third year, it's 1 minus 0.15. So you always got to be ready on SAT questions. Sometimes they don't give you the final answer. Sometimes they ask for the setup. So the setup looks like this. We started at $30,000. We then paid well, your car is worth 75% of its value. And then we have a 0.85 and then a 0.85. And you could go more years if you wanted to go more years, but that was basically what the question asked. And so now you just push all that into your calculator, and the correct answer should have been somewhere in the neighborhood of 16,256. There might have been some change, but that's where I rounded to. So the correct answer is C. All right. Number 2. I'm going to have to shrink this one up. For quality control, a company that manufactures light bulbs conducted different trials. And every trial, 500 were tested. So let me kind of go over here and shrink this down a little bit. It says 500 were tested in each trial. The bar graph shows the number of defective light bulbs found in every trial. So the question here, though, is in trial E, all right, so right here, in trial E, what percent of the light bulbs, okay, well, there were 500 total. So we're trying to find the percent that are defective of the total. So somebody walks around, grabs random bulbs off the manufacturing lines, takes it back to the lab, tests it, and I'm sure they have to have a certain output, a certain wattage or lumens. So if we look at E, that corresponds with 4. So trial E had 4 defective light bulbs, all right, out of 500 that we looked at. So that's a pretty small percentage. So what I'm going to do is I'm going to just divide that out. I'm going to go 4 divided by 500. And remember, this is going to give me a decimal, so I'm going to have to multiply it by 100 or move it over. But 4 divided by 500 is 0.008. All right. Well, now timesing by 100 or moving the decimal over, it looks like 0.8% or 0.8%. So a little less than 1% were defective. So the correct answer here is going to be C. All right. Number 3. Now I need to go over here and kind of make this screen a little bit bigger. That graph problem kind of threw us out of whack. That's pretty good. All right, at Lincoln High School, approximately 8% of the juniors and 6% of the seniors. So 8% of juniors, so 8% of the juniors, and 6% of the seniors did what? Were inducted into the National Honor Society. Now, if there were 418 juniors and 435 seniors, which of the following would be closest to and here's where we figure out what the answer is going to be. the total number of juniors and seniors that were inducted. All right. So the percentages aren't too bad. You just got to answer the question and combine them together. So 8% of juniors is going to be 0.08 times the total juniors, which was 418. And then we're going to add to that 6% of all the total seniors, which is 435. Must be a pretty big school. Let's just see what shakes out here. Now, we're probably going to get decimals, and we're going to have to ignore that because you can't have a decimal of a kid in NHS. But 0.08 times 418, so this is 33.44. So we're just going to call that 33 kids. Plus 0.06 times 435, that's 26.1, so we'll call that 26. So 33 plus 26 gives us a grand total of 59 inductees into NHS that year. So there we go. Next, number 4, the old moving company problem. We had one like this back in SAT, A or B or C, I forget which one it was, but I changed some things. So Andy's Moving Company, these are the charges that matter. The truck is $50 a day, so that's clue number 1. The next thing is it's 75 cents per mile, so that matters. The people get paid $15 per hour per person, so each mover gets $15. Now it says, Andy's Moving Company provided a quote for a truck and 2 movers. So we had 2 movers. The truck's going to be used for 1 day. So I'm going to color code this. So the truck per day used for 1 day. So right there, our truck price, $50. All right. And the total distance, so that was in red, the distance is 60 miles. So if it's 75 cents per mile, so for the distance, we're talking 75 cents times each mile. So what's that? 0.75 times 60. $45. So we got $45 in mileage. Then we had 2 movers. So we got the 2 movers. So we're going to have 2 times. Well, the movers get $15 per hour. So $15 per hour. And times how many hours? Well, it went from 2 to 7. So that's 5 hours. And so that comes out to be, that's 30, so $150 for the movers. So when we add all that up, 50 and 150 is 200, so that's going to be $245 total. And the question says, to the nearest whole percent, what percent of the total cost? So out of, you always put the out of down here, the total cost, what percent is the cost of the movers? So the cost of the movers was $150. So this is the cost of the movers, and this is the total cost down here. And it's over half, 150 divided by 245. I'm getting 0.6122, so times that by 100, or move it over. Looks like 61.2% is the moving cost. So there we go. Next question, number 5. This is similar to one that was on your either the A, B, or C. It was about a committee and teachers and parents and administrators, so I kind of modeled this one after that. But you have a marching band, freshman, sophomore, junior, senior. So those are our categories. Freshman, sophomore, junior, senior. And we have some percentages. So let's pop these percentages right here. 20% freshman, 25% sophomore, a quarter, 35, that's a big group in the band. Seniors, they don't tell us that, but I think we're going to need it. So remember, this should add up to 100%. So right now we have 20 and 25, that's 45 plus 35. Right now we're at 80. So we're missing 20%. So we should be able to get this just because they need to add up to 100. And it says the remaining 16 members are seniors. So the actual number that's in the band, there were 16 seniors. Now the real question says, how many more juniors are there than freshmen? So what we're going to need to do is we need to figure out how many juniors there are, how many freshmen there are, and then we're going to have to subtract the juniors minus the freshmen. That's going to be the answer to this question. Now, I can't find the freshmen or juniors because I don't know the total. You know, I know that this one is going to be 20% of the total. And I know that this one is going to be 35% of the total. But we don't have the total. But here's what we're going to do. We're going to use this piece right over here. We do have a piece of the total, and we do have the percent. So here's what we know. We know that 20% of sum total is 16. So 20% of some number is 16. So 20% of some number is 16. Well, to solve this, it's a division problem. Divide by 0.20, divide by 0.20, and we get x equals 80. So now I know the total. There's actually 80 members in here total. So to find our freshmen, we got to do 20% of 80, which that's going to be 16. Juniors, we got to do 35% of the total. So that's 24 plus another 4, 28. So how many more juniors are there than freshmen? 28, take away 16. Whew, it's a lot of work there. Correct answer, 12. So the whole key, the whole hinge of this is make sure that you can do, when you know the percent and you know the piece, you can use division to get the total. That'll open up everything else for you. Last one, number 6. An electrician spent 12% of his 10-hour workday driving to different jobs. So the other 88% of the time he was actually working, but he had to drive around to go to all these jobs. So how many minutes did he spend? Well, first of all, they give me 10 hours. So 10 hours, I need to change into minutes. So I'm going to need to multiply that by 60. So 10 hours is really 600 minutes. All right? And I need to figure out what is 12% of 600 minutes. Well, since that's the total, I do 0.12 times 600, which 12 times 6 is 72 minutes. So looks like he spent 72 minutes driving. All right, hopefully that got you up to speed on some SAT type problems to get you ready for the test. See you.